In section 1.2, let's look at applications and modeling with linear equations. We'll be solving applied problems, geometry problems, motion problems, mixture problems, and modeling with linear equations. To solve applied problems, follow these steps. Step 1, read the problem carefully until you understand what is given and what is to be found. So state what you don't know and state what you do know. So any knowns and unknowns. In step 2, assign a variable to represent the unknown value using diagrams or tables as needed. Write down what the variable represents. If necessary, express any other unknown values in terms of the variable. In step 3, write an equation using the variable expressions. Step 4, solve the equations that you just created. Step 5, state the answer to the problem. Does it seem reasonable? If it's not reasonable, check your work, make sure everything is correct. Step 6, check the answer in the words of the original problem, making sure all of the equations are satisfied. So let's try example 1. If the length of each side of a square is increased by 3 centimeters, the perimeter of the new square is 40 centimeters more than twice the length of the original square. Find the dimensions of the original square. So when you go through these types of word problems, underline things that are important. We're increasing the side of the original square by 3, and the new perimeter is 40 centimeters more than twice the length of the original square. And what we're looking for is the dimensions of the original square. So underline key factors in your example. In step 1, we read the problem. We must find the length of the original square. In step 2, we're going to assign a variable. Since the length of the side of the original square is to be found, let the variable represent this length. X is going to be equal to the length of a side of the original square in centimeters. So here I have a picture and I'm labeling each of the sides with X. That's the length of the original square. The length of the side of the new square is 3 centimeters more than the length of a side of the old square. So I'm going to increase each of these by a distance of 3 centimeters. This tells me that x plus 3 is equal to the length of a side of the new square. And so we have x plus 3, and x plus 3 is now the length of each of the sides of the square. Step 2, we're going to assign a variable. Write a variable expression for the perimeter of the new square. The perimeter of a square is 4 times the length of a side. I want you to recall the perimeter of a square is 4 times the length of a side. So we're going to take one of the sides and multiply by 4. That's how we find the perimeter. So we will take 4 times x plus 3, which is the length of the new square, and that's going to give us the perimeter of the new square. In step 3, write an equation. Translate the English sentence that follows into its equivalent algebraic expression. So we have the new perimeter, which is 4 times x plus 3, is 40 more than twice the length of a side of the original square. Now when you see the phrase is, that always represents equal. We have 40 more than, that means addition. Twice the length of a side of the original square. So 2x is the same as twice the length of the original square. And now from this equation we can distribute the 4 to the right side of this, and this gives me 4x plus 12 equals 40 plus 2x. So using distribution, we can simplify the left side. And so we have 4x plus 12 equals 40 plus 2x, and I can solve this for x. Let's subtract 2x to both sides, and I'll also subtract 12 to both sides. This gives me 2x is equal to 28, and now I could divide both sides by 2. Let's divide both sides by 2, and so x equals 14. This is the length of the original square. So we have 14 centimeters is the length of the original square. Step 5, state the answer. Each side of the original square measures 14 centimeters. In step 6, let's check. Go back to the words of the original problem to see that all necessary conditions are satisfied. Recall the length of a side of the new square would be 14 plus 3, which is 17 centimeters. Now take that and use that to find the perimeter. The perimeter of the new square would be 4 times 17, which is equal to 68. Now twice the length of a side of the original square would be 2 times 14, which is equal to 28. And if I were to add 40 to that, 40 plus 28 equals 68, and the answer checks out. Recall, we wanted the perimeter of the new square to be equal to 40 more than twice the side of the original square. And so since 40 plus 28 equals 68, our answer is good. In a motion problem, the component's distance, rate, and time are denoted with the letters d, r, and t respectively. The rate is also called the speed or velocity. Here the rate is understood to be constant. Now the distance formula is equal to d equals r times t, and we can also solve for r and rewrite our formula as the rate equals distance divided by time. Or I could solve for t and get the time is equal to the distance over the rate. So make sure you copy down these formulas. You'll need it for motion problems. Example 2. Maria and Eduardo are traveling to a business conference. The trip takes 2 hours for Maria and 2.5 hours for Eduardo, since he lives 40 miles further away. Eduardo travels 5 miles per hour faster than Maria. Find their average rates. In step 1, we read the problem. We must find Maria's and Eduardo's average rates. So we're looking for the variable r. So in this case, we're looking for r. I want to figure out what r is equal to. And that is for both Maria and Eduardo. Step 2, assign a variable. Since the average rates are to be found, we let the variables represent one of these rates. Let's let x be equal to Maria's rate. And so Eduardo is going to be 5 more than that, so Eduardo will be x plus 5, since he travels 5 miles per hour faster. Now in the table here we have Maria and Eduardo. Notice for the rate, Maria is x, and Eduardo is x plus 5, because he's 5 miles per hour faster. For the time, we know Maria took 2 hours to complete the trip, while Eduardo took 2.5 hours. Now on the very third column here, we use the formula distance equals rate times time, and basically multiplied across. X times 2 gives me the 2x, and that's the distance for Maria. X plus 5 times 2.5, that's the distance for Eduardo. And again, we use the formula distance equals rate times time. In step 3, let's write an equation. Eduardo's distance traveled exceeds Maria's distance by 40 miles. Translate this relationship into its algebraic form. Well, we know the distance for both Eduardo and Maria. We found that in step 2. We know Eduardo's distance is 2.5 times x plus 5, and Maria's is 2x plus 40. Now the 40 is from the additional 40 miles that she lives farther than Eduardo. And now I can use distribution. Let's distribute the 2.5 times x, and we'll multiply the 2.5 times 5. This gives us 2.5x plus 12.5 equals 2x plus 40. Let's subtract 12.5 to both sides. And I also want to subtract 2x to both sides. So this cancels out, this cancels out. So this simplifies to 0.5x is equal to 27.5. Let's divide both sides by 0.5 now. And so x equals to 55. Now remember, our units is in miles per hour. So this is going to be their rate. Step 5, state the answer. Maria's rate of travel is 55 miles per hour because that's x. And Eduardo's rate is 55 plus 5, which is equal to 60 miles per hour. Recall he traveled 5 miles per hour faster. Let's check our work. The diagram shows that the conditions of the problem are satisfied. Plug in these values into the original problem and you will know that these are good solutions. The distance traveled by Maria is 2 times 55, which is equal to 110 miles. The distance traveled by Eduardo is 2.5 times 60, which is equal to 150 miles. And if you check the difference between their distance, we have 150 minus 110 is equal to 40 miles. And we know in the problem that they have a difference of 40 miles between their distance. In mixture problems involving solutions, the rate or percent of a concentration is multiplied by the quantity to get the amount of pure substance present. The concentration of the final mixture must be between the concentrations of the two solutions making up the mixture. If it is not, then go back and check your work. There must be a mistake that was made. Example 3. A chemist needs a 20% solution of alcohol. She has a 15% solution on hand, as well as a 30% solution. How many liters of the 15% solution should she add to 3 liters of the 30% solution to obtain her 20% solution? Step 1, we read the problem. We must find the required number of liters of 15% alcohol solution. In step 2, let's assign a variable. Let x equal the number of liters of 15% solution to be added. And from here we'll create a table. So on the left side, notice that we have 15%, 30%, that's what we have on hand, and we want to create a 20% solution. Now, I don't know how many liters of 15% solution, so we call that x. We do want to use 3 liters of 30%, so that's why this is 3. Now the total is going to have to be x plus 3 because we're adding x liters of 15% with an additional 3 liters of 30%. Now I'm going to convert 15% as a decimal, that's equivalent to 0.15, and 30% is equivalent to 0.30. So we'll multiply 0.15 times x to get the amount of pure alcohol. And again, we'll do 0.30 times 3 to get the amount of pure alcohol for the 30%. And 20% is equivalent to 0.20. And when we multiply that by x plus 3, that gives us the amount of pure alcohol in the 20% solution. What you have to realize is the total of the X liters of 15% and the 3 liters of 30% has to add up to our 20% solution. And so we can create an equation. I can say that 0.15x plus 0.30 times 3 must be equal to 0.20 times x plus 3. In step 3, we want to write an equation. The number of liters of pure alcohol in the 15% solution plus the number of liters in the 30% solution must be equal to the number of liters in the final 20% solution. So let's create an equation. We have 0.15x plus 0.30 times 3 equals 0.20 times x plus 3. Again, we're looking at the amount of alcohol in the 15% solution added with the 30% solution to make our 20% solution. So let's multiply some of these values out and distribute the right side to create our equation. So I can simplify this as 0.15x plus 0.9 equals, let's distribute the 0.2, that's 0.2x plus 0.6. Now let's solve for x. Let's subtract 0.15x to both sides. And let's subtract 0.6. This would cancel out and this would cancel out. 0.9 minus 0.6 is 0.3. 0.2x minus 0.15x is 0.05x. Let's divide both sides by 0.05. And that gives us x equals 6. Now remember, this represents 6 liters. In step 5, let's state the answer. Thus, 6 liters of 15% solution should be mixed with 3 liters of 30% solution, giving 6 plus 3 liters, which is equal to 9 liters of 20% solution. In step 6, we want to check the answer. The answer checks since the amount of alcohol in the two solutions is equal to the amount of alcohol in the mixture. We have our 15% times 6 liters of solution plus the amount of alcohol in the 30% solution is equal to 1.8. Now if I plug in the 6 liters into the mixture, we have 0.20 times 6 plus 3 equals 0.20 times 9, which is also 1.8. So the amount of alcohol in the solution and the amount of alcohol in the mixture is the same. So that means we did our work correct. In mixed investment problems, multiply each principal by the interest rate and the time in years to find the amount of interest earned. Recall the formula for interest. Interest equals PRT. So we're going to multiply each principal by the interest rate, which is R, and the time, which is T. So again, make sure you note the formula for simple interest. I equals PRT. Example 4. An artist has sold a painting for $410,000. He invests a portion of his money for 6 months at 2.65% and the rest for a year at 2.91%. His broker tells him the two investments will earn a total of $8,761. How much should be invested at each rate to obtain that amount of interest? We read the problem. We must find the amount to be invested at each rate. Step 2, we're going to assign a variable. Let x be equal to the dollar amount invested for the 6 months at 2.65% interest. So whatever's left is going to be 410,000 minus x. That's the amount of money that we have left over. And that is equal to the dollar amount invested for 1 year at 2.91% interest. So let's create a table. On the first column here we have the invested amount. I don't know how much we invested at 2.65% interest, so we gave it a name, we call that X. We have the amount left over is going to be 410,000 minus X. That's going to be invested at 2.91% interest. Now, we're going to invest the first investment for 6 months, so that's half a year. That's why we have 0.15. And the other investment is for 1 full year. That's why we have 1 here for the time. And so we'll multiply X times 2.65 times 0.5 to get the amount of interest earned for the first investment. And then we'll multiply 410,000 minus X times 2.91 times 1 to get the amount of interest earned for the 2.91% interest. Now remember, we know that these have to add up to a certain value. These have to add up to $8,761 because that's given in the problem. The total interest must be a total of $8,761. So in step 3, let's write an equation. The sum of the two interest amounts must equal the total interest earned. So we have the interest from the 2.65% investment plus the interest from the 2.91% investment has to add up to $8,761. In step 4, let's solve our equation. So let's start by multiplying things out and distributing. We have 0.5 times 0.0265 is equivalent to 0.01325x. And now we're going to multiply this out. And this is 11,931 minus 0.0291x equals 8,761. Let's collect like terms. Let's add these together. And this gives us negative 0.01585 plus 11,931 equals 8,761. Let's subtract 11,931 to both sides. This cancels out. We have negative 0.01585x equals negative 3,170. Let's divide both sides now by negative 0.01585, negative 0.01585, and so x equals 200,000. Now this represents dollars, so this is $200,000. In step 5, state the answer. The artist should invest $200,000 at 2.65% for 6 months, and whatever is left, which is $410,000 minus $200,000, equals $210,000 at 2.91% for 1 year to earn $8,761 in interest. So we have to invest $200,000 at 2.65% interest and $210,000 at 2.91% interest to earn the $8,761 that we want. In step 6, let's check our work. The 6-month investment earns our principal is $200,000 times our interest rate, which is 0.0265, times our time is going to give us the interest of $2,650. While the 1-year investment earns, we have a principal of $210,000 times an interest rate of R, which is 0.0291, and the time is just 1 year, so we don't need to multiply by 1. This gives us an interest of $6,111, and if we add these two up, we should get the $8,761 that we need. So we know we did this problem correct. In example 5, if a vented range hood removes contaminants such as carbon monoxide and nitrogen dioxide from the air at a rate of F liters of air per second, then the percent P of contaminants that are also removed from the surrounding air can be modeled by the linear equation. P equals 1.06 F plus 7.18, where F is between 10 and 75 liters per second. What flow F must a range hood have to remove 50% of the contaminants from the air? So in this question, I want to plug in 50% into the P, and then we'll be able to find the value of F. To solve this problem, we'll first replace P with 50 in the linear model and solve for F. P equals 1.06 F plus 7.18. So let's replace P with 50. We have 50 equals 1.06 F plus 7.18. Let's subtract 7.18 to both sides. And that gives us 42.82 equals 1.06 F. Let's divide both sides by 1.06. Solving for F, we have F is equal to 40.40. This means to remove 50% of the contaminants, the flow rate must be approximately 40.40 liters of air per second. Example 6. The projected per capita healthcare expenditures in the United States, where Y is in dollars and X is years after 2000, are given by the linear equation. We have Y equals 331X plus 5091. Part A. What were the per capita healthcare expenditures in the year 2010? Part B. If this model continues to describe healthcare expenditures, when will the per capita expenditures reach $11,000? In Part A, we are given information to determine a value of X and asked to find the corresponding value of Y. Whereas in Part B, we are given a value for Y and asked to find the corresponding value of X. In Part A, the year 2010 is 10 years after the year 2000. So let's let X be equal to 10, and then we'll find the value for Y. Here we have Y equals 331X plus 5091. I'm going to replace the X with 10. So we have Y equals 331 times 10 plus 5091. And this would give me 8,401. In 2010, the estimated per capita healthcare expenditures were 8,401, just like we calculated. In example 6, part B, we're going to let Y be equal to 11,000 in the given model and find the value of X. Here, we're going to replace the Y with 11,000, and that's now equal to 331X plus 5091. To solve for X, we'll subtract 5091 to both sides, and that gives me 5,909 on the left, and that's equal to 331X. Let's divide both sides by 331, and so X is equal to 17.9, about 17.9. What this means is, this is about 17 years after the year 2000. The X value of 17.9 indicates that per capita healthcare expenditures are projected to reach $11,000 during the 17th year after 2000, that is, in the year 2017. Or you can say very close to the end of year 2017.